Hello there, welcome back. Welcome back to the Technology Innovation Hub. It's going to be another session from DevOps portal. I think to go back to the channel, let me share the screen. Now, because we have been building our competencies gradually, little by little, we are coming up. So if we just take a look at the channel, and now I think we are in competency level 3. If you go to playlist, let's check our in our DevOps portal. We have these are the competency levels that we have done up to now: CP1, CP2, and CP3. Yes, almost we did 5 sessions on CP3, that is getting familiar with Minikube. Right now I think we are almost a little bit familiar with Minikube environment, right? So now from this place onwards, we'll be starting the competency level 4 sessions, right? Practicals on competency level 4. So we'll start CP4 lesson 1 from this place onwards, right? Okay, so as a starter for that, let's do this, begin with this practical. So let's try to create some resources, right? So we know basic resources like port and service we have done, but let's build our knowledge on top of those things and get into the details deeper into the cluster, right? Little by little we are going deeper into the cluster, right? So this, let's see, creating resources. So it's going to be competency level 4 lesson 1. So the very first thing is let's create a second port which will enable port 80 and label, right? So you may remember we created ports with label, not with label. We did use label, right? So we use port, right? We use port using kubectl command, not with manifest file. You may remember we ran our Nginx, right? Nginx image, we execute that one. So with port 8080, but that is with a direct command, kubectl command. If you go back and see your practicals, you will notice. But now what we are trying to do, we are trying to enable the port with YAML file. That means with a manifest file, right? So this is what's going to happen. Create another YAML file, right? So you can see these, now, right? Version 1, kind 4. The only new thing is going to be this one, ports, container port. So this is how we enable a port, specific port, as per our requirement within the port. So we can give any port here, that doesn't matter, right? So, but since the Nginx also goes with default port 80, for the time being, we'll stick to default port. So I just want to introduce the new syntax. How do you give port in a YAML file, manifest file, right? So others we know, name, containers, Nginx container, that's fine, that we know, right? Okay, so let's create this manifest file and this run this particular, get this particular port up. So let's get back to here, and I think it's much, you can visible, right? Now it increased, right? Okay, so if I say get kubectl get PO, right? So currently I think I'm having my code is already there. So let's check the, I think I have the manifest file port 4, right? Yeah, so this is the manifest file, which include the container port 80, right? So if I want to run that one, I can say kubectl and create, right? -f, I can just say port. Yeah, yes, my code is already there, so it's already running, right? So since I have done this practical earlier, so that's why it is there. So let's delete that one, right? We can say kubectl delete CO, and we can run this, right? My code is deleted, right? So now I don't get my code here, so it's gone, right? So let's run this one now. Yes, so now if you get PU, you can see it's creating, container creating. So no big difference on those things, but the thing is, only thing is the port. Right, let's see how the port is going to be. So we ran this one and it's running now. Okay. So describe the port. Yeah, kubectl get PO my port. So if you describe it, right, should be almost up and running now. Now if you describe the port, you will see the port entry, right? This is our port IP and node. Here you can see the port is being distributed. Right? The port Y is indicating 80 because we have given him include this port, right? We need this port inside the container. So that's why. With the previous practical, if you go back and check, there was nothing here. It was empty, right? So since we included port, it automatically get that port into the container and enable it here, right? So that's why we can see that. Okay, so that is port, and now this example here we are trying to curl that one, right? So we can try that one. You may remember without curl we try to access via the browser earlier, right? So that's that you may remember we got the service created and all, but now we are trying to do a different thing. We are trying to curl the container. What is this 172.17.2? Let's check that one first. 117.70, 172.70.2 is what? You know that is a port IP. So what we are trying to do here, we are trying to curl the port IP private IP from my host. From outside the cluster, I'm trying to curl it, so which is not practical because 172 is a different network, right? It is within the cluster. Port is deployed within the cluster, so I won't be able to access like this. So that's why I say no route to host, right? But we know how this can be accessed using a service, right? Using a service, we did earlier using the kubectl command, but we need to learn how to do it on a manifest file as well, right? So let's continue our practical. You can see it was not, it will not able to access because it is within the cluster. In order to access the port, we need to create a service which exposes it to outside. Okay, that's what I just mentioned. So again, let's continue practical. Now I'm trying to introduce another syntax, labels, right? Label. So labels are very important in running manifest files, right? In production environment, we heavily use labels. Labels are key value pairs, identify resource attributes, like which application resource belongs to, right? Like to which application the resource belongs to, in which region resource, like you can read this and see. Labels can be used to filter resources. For example, listing resources in US West region, so that is in clouds. You can, yeah, because label is the way of categorizing the resources. Okay, we can say for this particular application, these resources are listed likewise, labeling. So if you see example, it should be much clearer for you. Now, in our case, we have this port, right? And port resource, we are trying to give a label telling it is a port resource belongs to web server because it's a Nginx image is going to execute it. So it's a web kind of a web application kind of a thing. So Nginx, so that we are labeling it as a web server. So this port resource belongs to this particular label. So using this label, we can identify whenever, right, wherever we can identify this particular container, my container, this port, my port is identifiable using this label. My port is identifiable using this web server label, right? So let's see what's going to happen. So we can just create this manifest file and run that one. Kubectl label port. I think label port. Let's check that one. Right. Again, it's running my port, right? Yeah, it's okay, right? So we are working on the same port. We can just again delete that one, right? Get delete port, my port. That's fine, right? I think get vi label port. Yeah, this one, right? Okay. So I have the label web server, right? So the port also there. Now port and label both are there, right? So this is specifically mentioned. This port resource belongs to this label, right? So let's run that one, hoop cattle, create, right, minus f, label pod, right? Okay, so now we have, so if you describe the pod again, describe pod, my pod, you will see now, there should be a label tagged here, right? So if you go up, you can see labels, it says app web server, right? Earlier, if you go and check the, I think I cleared that one, right? I think in the document output is there. Right? So in this document, if you take a look at the previous description, labels were none, right? So you can see we didn't include a label for the previous, only the port we included, no? But now we included the label as well. So if you describe, right? So as I mentioned, you should see, you saw that, right? You saw the label as well, right? So yeah, label for this created, okay, right? So you can see the label now. Yes, label is web server, right? So this my pod is accessible using this label and this identifiable using this label within the cluster environment. So that's one of the major benefits using labels, right? So let's further continue the practical, right? I think the document also continues. So it's being created. Now, what you're trying to do? Okay. Now let's try to create a service, because earlier this pod was not accessible. We tried to curl it, but we couldn't, right? Because it is deployed within the cluster. So from outside we can't. So we know the solution. We can create a service. We have created earlier. You may remember NodePort, load balancer we created, no, right? But now let's try to create the same, do the same thing using a manifest file, right? Access our Nginx web server, which is in the cluster, create the below YAML file. So this one is going to create a service, right? So if you closely monitor, we are not telling the port name here. This is kind service, right? And up to now, we have been using, I think, kind port. Now, for the first time, we are introducing another resource, the service resource. But now, this service resource is going to work with what? Our pod, my pod. But we are not telling my pod here. We are telling the label. You can see app web server label is there. So it knows this label is referring to my pod, which we just earlier created. Okay. And we are telling other keyword to go with the service. We are telling type is NodePort. Right? And you may notice there's another one, selector, which is indicating this NodePort service should select this label within the cluster and go ahead and create the service for that port, which indicates within this label. That's what it says. Selector. So I have explained it. Notice the spec. The selector defines the label to match the ports, right? The last one is optional. Type NodePort, right? Yeah. Anyway, by it is optional. By default, it goes for NodePort, right? So that will define how actually expose the service. It allocates a port for the service each node in the cluster. The designated port will be automatically selected. So that's why, it will create a port. It will select a port automatically. We know that. I have explained this. I think it goes from 32,000. I think I have given it here. It's any port between 30,000 to 32,767. That's how the ports are being assigned. Automatically assigned. If there are several ports running, which belongs to label, if there are several ports, what will happen? For each port is going to assign a port. That's what it says, right? So that will define how you can see that will define how to actually expose the service. It allocates a port for the service on each node, actually. So that's what, right? That's true. Because since we have only a single node, so it's not applicable to us, but later we can check that one with the multi-node cluster. But at the moment, since we have only one node, so so we'll have only one port allocated, right? So per node, not per port, right? Don't misunderstand. Per node is going to allocate a port, because you see in the node is the one which represents the cluster to outside, right? That we have done, right? Because node is the outermost layer. After that, we get the Docker, right? After that, we get the ports, then the container, like that, right? So node is the outermost layer. We have the IPs, internal IPs there. We'll see those things in a while. So whenever you want to access the cluster from outside, normally what we do is we get the IP of the node, right? And we use the port given by the service. That is the way, right? So that's why it says NodePort is defining a port per node. Anyway, we'll do the practical, we'll understand what I'm trying to say here, right? Ports are within the cluster, that's a different thing that we know, right? Per port, there will be a different IP, right? And when the NodePort is created, I mean, now in this case, it will limited using the label, right? So whatever the ports which are accessible for this label also will be accessible from this NodePort. That's all, okay? So then create a service as below. You can see kube cutl create. Okay, let's create this service, right? Service port, I think we should have that one. Yeah, it's service. Service my port. Yeah, we have service my port. Yeah, not port. That is correct, right? On that one. Service my port. Yeah, so it's already there web server. So I think let's we can delete that one. Kube cutl get svc. Let's check get svc, right? So we have the service kube cutl delete svc, that is web server, right? So let's now create it. Okay, so we can get the services again. Yeah. Right. So now this is our service. You can see web server type of NodePort. We gave NodePort. This is the cluster IP, right? So that is the IP assigned for this particular service. And we are not going to work with this one for the time being. And this is what we are going to work with, port, NodePort, right? Right. So let's go back and check our guide. So you can see get PO is fine and the service is created. Now if we describe the service, right? Very important to describe. Now we haven't done this one earlier. To describe the service, you will see more details. We have described a port, but we haven't described the service, right? So name web server, labels is working with this, right? And so again, let me show you, right? Why is setting web server, right? If I vi that one, we can see on the service find service name we have your web server. So yeah, that's why, because our label also web server, service name also web server. That's okay. Okay, that's fine, right? Right. So that's why we have labels web server and the service name web server and IP we have, right? So what are my IPs? And these are, you can see 10.9.188 10.96.188.4, that is the cluster IP source, right? And target port is that's 80. This is the endpoint. Endpoint means the port IP. Right. So don't worry about this IP for the while. For a while, we are not going to use that one at the moment. So, but try to understand this one. This is the endpoint, right? Endpoint means now for our particular port, my port is running only one port here or one replica. So we have only one endpoint. So if we have 3 replicas or 3 ports for our application, we will do it later. We are going to have 3 different IPs and 3 endpoints. That's what's going to be, right? So at the moment, there's only one endpoint. This is what is exposed within the cluster to outside. Because you know, when you're creating the port, we mentioned to use port 80 for the for the container, for the Nginx container. So this one is going to get exposed to outside using this NodePort. That is the mapping means. You can see the mapping. 80 is the container one. This one is the outside mapping, right? And so that's why I'm telling it's an endpoint. So this endpoint is accessible via this particular port, right? So, and that's when if you want to curl and see, the previously curl failed, right? We ran a curl. Endpoints are the address of each port. That's what I just mentioned, right? Coop control, yeah, describe node. So this is another command. Now let's try to describe the nodes, right? We have only one node, it's a single node cluster, right? I think you got this one. So let's describe the node also and see. Okay, it will be lengthy output, but doesn't matter. So we have describe node. So let's leave here. The very important thing to notice here, this one, we have this internal IP, this one. What is this? This is the Minikube IP, right? So that's why I mentioned earlier. Now, if you want to access whatever the resources inside the cluster, now the NodePort is exposing it to outside. So we use this internal IP, which is represented in a node, and the internal port exposed by whatever service, either load balance or NodePort or cluster IP. Right? Okay, for the time being, let's say NodePort, because we created a NodePort service, right? So that's what here we can see again. I think if you go down now, if you try to yeah, Kubectl services web server. Okay, with this get services web server. Okay, now we have already done that one. No, here we check that. Okay, now we can curl that one. Curl and our IP, right? So let's try that, right? This is our IP. I think we need to get our IP. This one, right? So let's take this IP. We can do curl. So say HTTP is fine. So and colon. What is the port? Our node port, which is given by the service. This one, right? Kubectl get service. It shows web server node port. So we give this port, which is exposed to outside. So if you now curl it in this way, what should happen? Should be able to access, right? Which one? Nginx page. You may remember we access the same page using the browser, right? So now here, this is what it says, whatever the same output. This is the ping message from Nginx container successfully installed, and likewise, right? Thank you for using Nginx. So earlier this was failing, right? Because we tried to access using the pod IP, which is not visible for outside. But now what we are doing from our node IP using our port, which is exposed to outside from within the cluster using NodePort, then we access it within that, right? So let's try to get the concepts here, right? How it works like, right? So that's why using Minikube, we are trying to understand all the basics, right, prior to going to the Kubernetes cluster. Okay, I think yeah, get services web service, that's right. Okay, curl work, fine. And yeah, so curl will send an HTTP request. The output will be the HTML output by Nginx. That's true. Above 192.168.49 to the node IP of the Minikube server. It is possible to curl and ping the port which is inside the cluster as the port is exposed to outside using the NodePort, whatever the port 32126 in our case, right? All right, so I think you got the idea, right? The NodePort and how the labels and the port and the service exposing the service using NodePorts and accessing those things using manifest files, right? Okay, right. So the next practical will be on scheduling resources and nodes. So that we will do it on the next session. All right. So I'll stop here. So I'll meet you soon in the next session. So if you like the video, you can put a subscribe. All right. Have a great time ahead. Bye bye.